Okay, welcome to shop measurement and calculations discussion of temperature measurement systems. So today we are going to talk about how you measure temperature. This is probably going to be pretty basic for most of you, but there are going to be a few tidbits of interesting stuff. What I'm going to do is talk about Celsius and Fahrenheit in very generic terms. We're going to talk about methodology to convert from Celsius to Fahrenheit, and I'm going to encourage you guys to cheat. Okay? I'm going to encourage you guys to cheat. First of all, let's talk about the two scales. Celsius is the European standard, CE standard, and it's not the same scale starting point as Fahrenheit. Fahrenheit 0 degrees is well below freezing. It's 32 degrees below freezing in terms of Fahrenheit scale. Whereas Celsius, 0 is freezing point of water at an atmospheric pressure equivalent to the level of the ocean. So water freezes at slightly different temperatures depending on the conditions and the content of the water. But we're going to pretend that there's a generic degrees, 0 degrees C, where water freezes. So the key is, how do you, in your head, convert the two? If you hear 35 degrees C or 40 degrees C, how do you convert between those two things? And the first thing I'm going to do is teach you guys how to cheat. And what I'm going to do is share my screen here. And what I'm going to do here is I'm going to say convert to Celsius. And Google gives you a lovely tool instantly to cheat. So if I want to know what, say, 35 degrees Celsius is, it automatically tells me that's 95 degrees Fahrenheit. If I see 40 degrees Celsius, it tells me it's 104. So if I have a forehead temperature of 40 degrees Celsius, guess what? I'm going home. That means I'm sick, 104. Probably means that I need to go get myself a COVID test in today's world, because having a high fever in the current environment is not something you want kicking around the classroom. And I don't want to transfer it to anybody I see in the classroom. So this is the easiest way to cheat from Fahrenheit to Celsius. Or if I want to go back the other way, I can use this tool. Say if I want to know what 75 degrees Fahrenheit is, it tells me that that's 23.88889 degrees Celsius. So if I see a 24 degree Celsius day, that's usually a pretty nice day. It's a pretty lovely, warm but not hot day. So that's the first way of cheating. You, of course, will be able to use your pocket reference book, and I just wouldn't grab my book, and come up with a formula to convert from Celsius to Fahrenheit, and we'll be doing more of that later in this course. But honestly, I don't expect you guys to use this ever. 98% of the time, you're going to be in zone somewhere on the internet, and you should be able to run this calculation on your phone. Super easy, and you can read. There's download. You can download an app to do this as well. So this is a really, really easy thing to do and cheat. And I encourage you guys to cheat. But when you cheat, make sure you round. Don't use 0.8889 degrees Celsius, because most thermometers don't have accuracy down to 4 decimal places. In fact, none of the ones you can buy in an ordinary place, an ordinary store, are going to have that kind of accuracy. So let's take this moment to dive into a number of thermometers. And what I'm going to do is go to my overhead cam And now we're going to talk about our thermometers in the real world. And I've given you a range of different thermometers here. One that you guys are probably familiar with at this point is your oral thermometer for measuring temperature of a human being, usually stuck under their tongue. And this particular device is very, very simple to use. You press the button on the back and it tells you when it's ready, and then you put that inside your mouth, under your tongue. Actually, I think I have it upside down. And this particular thermometer is set up for a very limited temperature range. It's only set up for a range that would be valid for a human body. So when you're underneath, I think 90 degrees Fahrenheit, it doesn't even read a valid temperature. So what I'm going to do here is stick it under my tongue, give it a second. Here, let me switch cameras so you can see this. As I show you, an active temperature test. Now, all of you guys should be used to this sort of stuff, right? I can see it slowly going up. Now, this thermometer is smart enough to analyze the temperature and give me a reading when it sees that the increase in temperature stopped rising. In other words, it plateaued. It went up, it slowed down, and then it stopped rising. That means the thermometer had risen to the temperature of the environment for which it had been placed. So this demonstrates three key features of accurate temperature measurement. Number one, it was fully immersed in the environment that it needed to measure the temperature. Number one, it wasn't on the surface, it wasn't nearby, it was fully immersed. That means the sensor probe was fully immersed and is going to be accurate to the center of whatever you're measuring. Secondly, it was given time for the mass of the probe to reach stability. So the mass warmed up and the temperature reached a stable point. That's the second. Number three, it had really good contact with the object that was measuring, which case is my human body, and it was stuck under the tongue and pressed really hard against it. So full immersion, excellent contact, and given the time to reach the temperature of my human body. So those are three very, very important ideas about temperature measurement. So that is your classic measurement system. Now, the advantage of this system is it's automatic and it looks at temperature stability as it rises. It's relatively accurate. It uses a thermistor, not a thermocouple. Thermocouples are, we're going to learn more about them in sensors class, but thermocouples are a little bit less accurate. They're probably an accuracy of 2 degrees Fahrenheit, whereas thermistors are usually an accuracy of 0.5 degree Fahrenheit. And so this little device, this little cheap device here is an example of a technology that's really quite excellent. It's got built-in brains. It costs less than $15, and it still does an excellent, excellent job of temperature measurement. In the old days, we had bulb thermometers with less automatic features. Obviously, you stick a bulb thermometer, it doesn't tell you into somebody's mouth. It's not going to tell you when it's reached stable temperature. You just have to wait. And the second thing about the bulb thermometer is it's also not going to tell you you've had good contact, and it's potentially dangerous if it breaks because you have mercury everywhere in the old school bulb thermometers. So that's an excellent temperature measurement device. The second one that you guys are probably familiar with now is the thermal imaging devices. In this case, I've got a generic infrared thermometer that by measuring the image, measuring the thermal emissivity of what it's shooting at, it can measure the temperature. So is this as good as my other thermometer? If I'm shooting your forehead with this, is it going to be anywhere near as accurate as this thermometer with had all those nice features? This doesn't tell me when it's reached a stable temperature. It's measuring only the surface. So what if my forehead is sweaty and the sweat helps the forehead cool down a little bit? Is it going to be an accurate temperature measurement? And the answer is no, it's not. But it's a lot more flexible, and it's a lot quicker, and it doesn't put me in contact with my patient. So even though it's not as accurate, it does a pretty good job. Now, generally, you just pull the trigger on these. It aims at your target. Let's see if I can aim this. I'm going to turn off the little light there. All right, it aims at the target and it measures the surface temperature of my target. In this case, it's measured the temperature of my table, which is a lovely 76.6 degrees. It actually is a lot more accurate than thermocouples, and probably even more accurate than the thermistor, which is in my little oral thermometer. Another big advantage of this is it can switch to Celsius by the press of a button. So by pressing one button, I can flip it to degrees Celsius or back to Fahrenheit. So this is a second way of cheating and getting Celsius versus Fahrenheit. And many, if not most, digital thermometers that are sold are easily switched between Celsius and Fahrenheit. And the reason for that is because many of these are sold, they're produced and sold in China. And the Chinese are very smart. They want the units to be able to sold in Europe as well as the US. So they make it generic so you can flip back and forth between each of them. So there are some advantages to this. It's quicker, it's non-contact. There are some disadvantages. It's less accurate, and it doesn't tell you if your measurement is stable. It doesn't tell you that. This right here is an example of a really high-end thermometer. This has the advantage of measuring temperature and also logging that data and letting you hook it up to a computer. And it's extremely accurate and is the advantage of being calibratable. I can use this with a temperature probe. This is a $500 version of something that you guys probably are familiar with. Well, we're going to show you this one first because this is the one, hopefully, if you've ever cooked any meat in your life, you've used. This is a meat thermometer. It's designed to be turned on. I've got a little button on the back that lets me switch to degrees Celsius or Fahrenheit. And all it does is give me a temperature reading, and it's hooked to a probe. See this stainless steel probe? This is the one I use every time I cook any kind of meat in the oven to make sure the meat's done properly and safe, right? Oops, why am I getting a low reading? Okay, this one's quite old. It's probably 20 years old, and the probe itself is starting to wear out because it's been closed in the oven door too many times. But in this case, it's got a long stainless steel probe that's washable, ending in a tip where your actual thermocouple sits. That's where your coupling that generates your measurement sits. So if I warm up that tip, you can see that immediately my temperature starts going up. Now the accuracy on this is not nearly as good as my oral thermometer, and it's going to be probably plus or minus 2 or 3 degrees, which means it jumps in 5-degree increments as I warm it up, which is fine for cooking meat. If, generally speaking, you want to be within 2 or 3 degrees of your target temperature, but not so good if you're measuring someone's body temperature in case they have a disease. But this is a relatively inexpensive device. I think this little sucker was a little bit pricey when my parents bought it for me 20 some odd years ago. But you also can buy the same thing to look like this. So this is a standard manual meat thermometer. It uses a little probe which has so-called bimetal probe. When you warm up these two pieces of metal that are twisted together, they untwist a little bit. So as I warm this up, you're going to see that little dial rise up into the range that's valid for cooking done meat. And so what's the huge advantage of this little sucker? Number one, I never have to worry about batteries. Number two, it gives me all the information that I need to cook my meat till done right on the face of the thermometer. If I wonder what medium rare beef is, then I can see right there, medium rare beef is 145 degrees Fahrenheit. And that's true for beef, veal, lamb, and pork. Do I want medium rare pork? Well, in the old days, I never would because we worried about disease. But in modern days, it's pretty rare to find a problem with pork. Nevertheless, I still never cook my pork medium rare. I always cook it medium well or well done. Gives me a temperature for poultry as well. It gives me a bunch of data. It never runs out of a battery. And all I have to do is make sure that the probe goes down into the center of meat. So it's got good contact with the meat. It's got total immersion. And it's given enough time in the oven to reach stability, and the probe temperature is equal to the interior of the meat. So this is a very important methodology in terms of temperature measurement. I can get the same thing from this guy. It is a lot more accurate, and I can buy these probes in a variety of formats. In this case, this is a probe that's about 4 feet long. The end of the probe is this little bulb right here. That's the thermocouple junction that you actually use to measure the temperature. If I want to plug this probe in, I would just flip up my device and turn it on. And now we can see that I'm getting a measurement from this system here for probe number 1, right around 77 degrees. This is a more accurate system than my cheap-ass meat thermometer. It uses some calculations to give it a better accuracy, even though it's also just using a thermocouple. So the probe itself doesn't necessarily give you the final story in terms of accuracy. Sometimes the measuring device does that as well. So what's the advantage or disadvantage of this system is dependent on the probe. This particular probe is a high temperature probe. I can stick it into something as hot as 1,000 degrees, which I have. Not this particular one, it's new, but I've stuck an identical one into a lamp system measuring temperature of 1,000 degrees Fahrenheit. In fact, for me, probes are disposable. When I'm measuring something that hot, the probes don't last very long. It only measures accurately for a little while, and then the temperatures go wanky and I throw away the probe. When you're measuring a lamp system, you have to have the end of the probe in contact with the lamp bulb. So you have to make sure this is pressurized in contact. And it's really hard to do a surface measurement like that, really, really hard. And there's a whole video about surface measurement that you can find on YouTube. When you're doing surface measurement, you want to make sure that your measurement device is securely adhered to the surface. On the bulb system, I use a spring-loaded device. But if you're measuring the temperature of say a duct, and you would use a little probe that's designed like this. This is actually a temperature probe with a little eye at the end of it that I can screw down to get a really accurate surface measurement. Not nearly as accurate as getting inside the chamber, but better than just pushing up against something. So surface measurement is actually kind of challenging. So these are all handheld devices. You're not going to find them in any sort of automated configuration. They're used by operators to check measurements on the fly. In the case of this operator, this is a chef or a home cook. One of these devices here is something you're going to find in automation. This is a device produced by a local company out of the York area called Red Lion. This is a temperature control device. And this particular device is designed not only to read the temperature, but also have an output to turn on and off, say, a heater if you want to control the temperature. And it's very easy to use. I would just take one of these thermocouples here and screw it into the back of the device on two of these contacts, and we're not going to get into how you wire it up. How you wire it up is right on the side here, but we're not going to dive into the details of that. And then this device right here then can measure the temperature accurately as well. And this device has got the same sort of accuracy as to maximize the ability for this thermocouple in terms of accuracy. So those are a handful of different temperature devices. We talked about, I'm going to switch my screens here. We talked about different measurement methodologies. And the idea is, number one, Celsius and Fahrenheit, you have to understand what those two scales mean and how to flip between them and how to cheat and calculate one versus the other. Number two, you have to recognize that most electronic devices allow you to flip in between them. Number three, I'm encouraging you to dive into how all these different electronic devices work. Now, I have given you guys an assignment about meat thermometers, and I'm going to require that you use a meat thermometer. Now, some of you may not have one in your apartment, but I believe that it is a critical device for anybody who cooks at all. So I'm going to encourage you guys to go get one.